Welcome to aminacademy.com. In numerical methods and analysis, we discuss about central differences. Now, in the previous videos, we discussed about Newton's forward and backward interpolation formulas. That formulas are suited for interpolation near to the beginning and end of the differences. But now we'll discuss about the values if we want to find the values of x near the middle of x values, we can use central difference method. Now we'll discuss this method. The central difference method can be used when x values x value x value to find to find to find which is nearer to central data, nearer to central data or or middle data. For this system, we had to use central difference formula. Now look at this. We know that let the central difference operator, let operator is delta and defined by delta yx is equal y of x plus h by 2 minus y of x minus h by 2. Now yx plus h by 2 minus yx h by 2. Now for example, look at this. Y of minus 1 is minus y of minus 2, next one is equal to delta y of minus 3 by 2, means minus 1 minus 2 is minus 3 divided by 2, and y of 2 minus y of 1 we can say is delta y of 3 by 2. Like this we can use the central difference formula. Now let us try to fill the table to understand further about central difference. Here the x values are given as x of minus 3, x of minus 2, minus 1, 0, like the center value is x0 and y value is y0. Now the first difference, second difference, third difference, fourth difference we are using. In that delta y, first difference is delta y of minus 3, that is equal delta y of minus 5 by 2. Like this, delta y minus 2 we can use equal delta y of minus 3 by 2. Here delta y of minus 3 equal small delta of minus half. Then for center values, delta y of 0 is equal to delta y of positive half, and for delta y1 is of equal to delta y3 by 2. Like next is delta y2 equal delta y5 by 2. Delta y half 3 by 2 half 3 by 2. Then 5 by 2 like. Now second difference is we can say delta square of y minus 3 is similarly like delta square of y minus 2. Like here delta square minus 2 is equal to delta square y of minus 1. Here delta square y of minus 1 equal delta square of y of 0, and next is delta square y of 0 is into delta square of y1, and delta square y of 1 equal delta square of y2. Now third difference is delta cube y of minus 3 equal delta cube of y of minus 3 by 2. Like that, delta cube of y of minus 2 equal delta cube of y of minus half, delta cube of y of minus 1 equivalent to delta cube of y of 3 by 2. Then fourth difference is delta power 4 y of minus 3 equal delta power 4 of y of minus 1. Next, delta power 4 of y minus 2 is delta power 4 of y0, and delta power 4 of y of minus 1 is equivalent to delta power 4 of y1. Like it continues. From this, we can find some other formulas like central difference formulas, Stirling formula, Gauss forward backward formulas we can find. We can derive from this system. So we'll see that coming videos about Stirling formula, Gauss backward and forward formulas. We have done. Please subscribe our YouTube channel.